Good evening, class. So, in the series of Fundamental of Maths, yesterday we were talking about the normal form of the equation of the line, in which we had derived the equation which was consisting of both the variables x and y and the r. R was the distance between the point xy and x1 y1. Both the points xy and x1 y1 were lying on the same line, and we had derived an equation which was entitled as the normal form of the equation of the straight line, and the formula was x minus x1 by cos theta is equal to y minus y1 by sin theta is equal to r, where r is the distance between xy and the point x1 y1. Okay, so we had derived that equation, and the theta was the angle of inclination of that particular line along the positive direction of the x-axis. So till yet in the coordinate geometry we had covered the topic related to the equation of the straight line, the circumcenter, the incenter, and other topics which we had covered. So today I will be covering one of the most important topic, and it is this type of topic. It is more applicable in all the fields of the coordinate geometry in solving the various type of numerical problems. So today we will be discussing about an important concept which is known as the distance of a particular point from a particular line. Suppose the equation is given. It is in the form of ax plus by plus c, and an exterior point it is given xy. So in that case we have to calculate the distance from that point to the particular line. So this type of numericals, we are coming across various type of things, such as in the field of the coordinate geometry, in the field of algebra also, how to find the distance of a point from the particular line in a given space. So we will be deriving an important equation using the concept of the triangles, so that we will be getting a simplified form of the equation and how to calculate the distance from a point to the particular line. So we will be doing one important derivation here, and first of all we will draw two axes, the x-axis and the y-axis. The horizontal axis, it is known as the x-axis, and the vertical axis, it is known as the y-axis. And we will be taking one straight line equation, ax plus by plus c is equal to 0. We will transform that equation into the intercept form of the equation, where x by a plus y by b is equal to, you can say, is equal to 1. X by a plus y by b is equal to 1, where a is the intercept made on the x-axis and y is the intercept made on the y-axis. So we had transformed that equation, ax plus by plus c is equal to 0. We had taken the constant c to the right hand side of the equation. We had taken the constant c to the right hand side of the equation, and we had divided that particular constant by x by minus c by a plus y by minus c by b is equal to 1. So we are getting the intercepts on the x as minus c by a and on the y as minus c by b. So we had got the two intercept, and for the x-axis the y coordinate will be 0, and for the y-axis the x coordinate will be 0. So based on that we had written the various type of coordinates here. On the x-axis minus c by a common 0, and on the y-axis it is 0 minus c by b, and one point we had taken, it is x1 y1. So we had got a triangle entitled as RPS. This is the triangle RPS. This is a shaded figure. This shaded figure shows the area of the triangle. So we will be calculating the area of the triangle using two concepts, and we will equate both the concepts, and we will take the distance Pn. As of now we have to calculate the distance Pn here. So we will be equating both the equations, and from that equation we will be calculating the Pn. The Pn will be the height of the triangle, that is the distance of that point P x1 y1 from this particular line. So that we have to calculate. First and foremost, using the coordinate geometry, we will derive the equation of we will be using the formula for the area of the triangle, and we will just find out the area of triangle in this case. So area of triangle formula is half of x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So we will be using this formula, basically half of x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. This formula we are using for finding the area of triangle whenever we want to calculate the area of triangle in the aspect of the coordinate geometry. So in this case we will be substituting the values of x1 y1 x2 y2 x3 y3 in the given equation. So it will be mode of this one. So it will be half of x1. Suppose we had taken the x1 as this one, minus c by a. So we will be writing here minus c by a, y2 minus y3, y2 minus y3. So we will be writing here y2. Suppose we want to take y2 as minus c by b, and y3 we will be taking as y1. Understood? Okay. Now we will be taking x2. The first and foremost, the x2 will be equal to 0. So this term will be 0 plus x3. x3 will be x1. The x3 which we had taken here, it will be here x1 y1 minus y2. So y1 will be 0 and y2 will be plus c by b. Okay, so we will be enclosing it with the bracket. So we had got the result here, half of c square by ab plus c y1 by a plus c x1 by b. So we had got the answer here, that is half of x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Half of x1 we had already taken minus c by a, y2 minus y3. y2 it is we had taken minus c by b, and y1 we had taken here, that is y3 y1. Understood? So we had got one answer here, it is this one. Understood? Now we will be calculating the area of triangle using the formula which we had studied in the lower class, half of base into height. Half of base into height. So we will be applying that formula only. The first and foremost we will write here x1. x1 is minus c by a, y1 is 0, x2 is 0, y2 is minus c by b, and x3 it is x1, and y3 it is y1. So we had used this, we had substituted these values in this corresponding formula. Half of x1 minus c by a, y2 minus c by b, and it is minus y1 plus x3 it is x1, y1 0 minus y2 minus 1 plus c by b. Half of c square by ab plus c by 1a plus c x1 by b. So we had got this answer, half of c square by ab plus c by 1 by a plus c x1 by b. That result we had got here. Now we will be equating this with the basic formula, that is half of this one minus, we will take this coordinate 0 minus c by b and minus c by a 0. Minus c by a 0. So we will be taking the distance rs, half into rs into pn. Now we will be solving this in this way. We have to delete this one because the space is less. Now the second case, we will be calculating the area of triangle is equal to half into base into height. What is the base here? Base, we have to calculate the distance between these two. The base will be equal to, suppose the base will be equal to under root 0 minus 1 plus c by the whole square plus c by b the whole square. Now base we had already taken, base is equal to c square by a square plus c square by b square under root. The base will be equal to a square b square. Now it will be c square b square plus b c square a square. Understood? So we had got these two result here. Half into base into this and half into base into this. We will be taking out this one. Suppose we had taken the c square here common. So we will be taking out this c. Both we will equate both these two. Both this triangle we will equate here. And we will be getting final answer as, we will be getting the final answer as the distance from a point to the particular line. So we will be getting that as answer. I will just show what is the formula for that. We will be getting the formula for the same is equal to ax1 plus by1 plus c by under root of a square plus b square. This is the distance of a point from the particular line, where x1, y1 are the 2 points from where we want to calculate the distance from that point to this line. So this is the particular formula, ax1 plus by1 plus c by under root a square plus b square. So this is the formula from the point x1, y1. So in the given question, from this equation, we are deriving the two types of questions here. The first question, it may ask in the examination that a particular point is given and from that point we have to calculate the distance. So it will be easy for us to calculate the distance using this particular formula. Second case in this, suppose if a particular point is given, distance is given, so we have to find out the equation, or we have to find out the constant in that term. So this is also the second type of the question which may come in the examination. Suppose as an example, we will take one example. Suppose to calculate the distance of a particular point. Calculate the distance point, if you want to take point 1, 2, and from the equation suppose it is given 3x plus 4y plus 5 is equal to 0, and the point it is given 1, 2. So we have to calculate the distance of that point 1, 2 from this equation of line. So we will be substituting the respective values in the corresponding equation and we will be getting the answer as soon as possible. Suppose this is the point here. We will be taking a as 3 and the x1 will be taken as 1. B will be taken as 4 and the y1 will be taken as 2 and c is 5. We will be using under root a square plus b square, that is 3 square plus 4 square. So it will be 3 plus 4, 3 plus 8 plus 5. So it will be equal to 16 by 5. 16 by 5 units. So that point 1, 2, it is located 16 by 5 units from this equation. 3x plus 4y plus 5 is equal to 0. So in this way, we are calculating the distance of a particular point from the equation of the line. We will be taking some more examples so that it will render more transparency in this case. We will be taking some few more examples in this. Suppose in this case, we have to calculate the distance of a particular point from the origin. From the distance of a particular point, that is, that point is origin, and we have to calculate the distance from the origin to the corresponding equation. Suppose the equation is given 5x plus 12y minus 30 is equal to 0. And the point it is given 0, 0. So in this case, we will be using the equation ax1 plus by1 plus c by under root a square plus b square. We will be using the equation ax1 plus by1 plus c by under root a square plus b square. In this equation, we have to carefully find out what is the value of x1, y1, a, b and c, a square plus b square. Thereafter only we will be able to calculate the distance easily. Suppose here it is ax plus by plus c is equal to 0. Then in this case a is equal to 5, b is equal to 12, c is equal to minus 30, and a square plus b square we had already found out, and the x1 it is 0, y1 it is 0. So we will be calculating the respective values. A is 5, so 5 into 0, b is 12, 12 into 0, c is minus 30, by under root a square plus b square, that will be equal to under root 169, that is 30 by 13. We had calculated here the value minus, it is minus 30 by 13. Under mode it is, when we are taking it out, it will be 30 by 13. So we had calculated the value as 30 by 13. So in this case, we had seen how we are calculating the distance of a point from that equation of the straight line. It may be from the origin, or it may be any point in the given space. How we had derived the requisite formula. So it is one of the basic formulas which we are using for calculating the distance of a particular point from that equation of the straight line. So it is an important topic which we had discussed today. So from tomorrow onwards, we will be discussing the distance between the two parallel lines. And after that, thereafter we will be covering the topic of circle in the aspect of coordinate geometry. So this is all about today which we had discussed. Please carefully observe the video, see the video, like it, and please subscribe it. If you have any issues, please comment in the comment box, so that I will be getting an intimation regarding the questions or the difficulties which you are facing, and I will try my best first to solve these issues within the shortest possible time. So thank you for today. Have a nice day. Good night.